This chapter is on extracting rotations. Like I said, we're going to use two different methods to extract the rotations and be able to drive a twist bone. With the forearm, we used constraint system. It's very simple, very fast to use. Quite frankly, a great way of doing it. I'm not sure there's a big advantage of using script controllers other than showing you that you can actually extract a rotation and drive something with it. This can be used in many different areas of a character rig, many different ways, where maybe a constraint isn't practical or isn't going to do what you want. In this case, we want to drive the local x-axis along the twist of this bone. And we're going to use a script controller to do it. We want to extract the rotation difference only on the local axis of this compared to the local axis of this. Now the problem being is the upper arm bone and the clavicle bone aren't aligned at all at this point. So that means that any rotation value we get is going to be some arbitrary value to start with. It could already be rotated by, X amount of degrees. We want to start with 0. Our X value is currently 0. So we want a 0 value to start with. And it's best to work it that way and make sure that we extract something that's starting at 0 and going up and down from there, and we'll get a better idea of what we're doing. To do that, I'm going to use another object. I'm not actually going to extract the rotation from between the upper arm and the clavicle. I'm going to extract from the upper arm to some other object. That other object in this case is going to be a point helper. I'm going to align the point helper up to the upper arm and then link it to the clavicle. This way I know that this object and this object are aligned together in orientation, and when I extract a rotation between these two at the default pose, it will simply be 0. The twist bone is already been linked up to the upper arm bone, so I'm going to go to the motion panel with the twist bone selected. I'm going to go into the rotation X value that we want. I'm going to change the controller to a float script. Now this float script is showing us a value already that the bone has been rotated at along the x-axis. This is an exponent value, so this is about as close to 0 as you're going to get. So 0 would be the same sort of thing. If I said evaluate, you won't see the bone move. I want to leave the 0 in there for now, just so that I can not have errors happen as I'm writing the script and can test parts of the script as I go. We're going to add to this script as we go and change it. But first off, if you want to make a script controller, just a default script controller, interactive on screen when you're moving things, you have to use a depends on statement. The depends on statement basically says that this script controller depends on an object for its values. And in this case, I'm going to say depends on, and I'm going to use this bone and depend on the rotation of this bone basically. So I'm going to take this bone and copy it into my script controller. I use a $sign previous to the name of the bone, because the $sign tells MaxScript that this is an object in the Max file that I'm currently targeting and looking at. It isn't just a variable called bone07, it is an actual object in the scene. It isn't going to matter to our script, but it will when I start showing how other parts of it work. I'm going to also make it depend on the point helper as well for now, to show you a little bit more about how the two interact together. We have to use a bit of math now, a bit of matrix math, to be able to extract the rotation from one to the other. Like I said, you can't just pull a local rotation out of that bone and expect to get something that's going to be useful. It's not. Every object sits in parent space. You need to get the local rotation value in a sense, what people call local rotation, by extracting it. The way that's done is by multiplying the transform of this object with the inverse of this, and we will get basically the local change between the two. So I want to create a variable called rot for now, and that's going to hold the whole rotation value. And I'm going to, inside of brackets, say $Bono7 dot transform multiplied, and you have to multiply it by the inverse of the other transform. So inverse so we're going to multiply this bone by the inverse of this helper object. Oops, I forgot my equals sign. So rot is going to equal this, and I'm just going to say print rot, and I'm going to open the listener and hit evaluate. What it's done now is actually it's printed out the information that's now stored in the variable called rot. This is a matrix, and what we're looking for is a rotation. In actual fact, we're looking for an Euler rotation. So the next step I'm going to say is dot rotation. So this will get the rotation part out of the transform that we're calculating inside those brackets. Hit evaluate, and you can see that I'm now getting a quaternion value. It's basically a zeroed out quaternion value. Still not what we want, because we need an Euler value, an XYZ value. To do that, I'm going to say as Euler angles after it. So as Euler angles, if you check in the help file, will convert a quaternion into an Euler value. Press evaluate again, and now you see the Euler angles. We've got these very small exponents, it looks like. So essentially that's 0, 0, 0. It's very close. To get the x value, we'll go, just say in this case, print rot dot x. And there's the x value for it. So what we can do now is we can use this to drive the x rotation. I'm going to delete the 0 now and delete the print statement, and we're just going to use the value that's here. So I'm going to say evaluate. Pick my bone, and I'm going to put a fin on it just so again we can see what's happening to it. Pick my elbow control, and you can watch as the elbow moves up and down. You can see the bone rotating wildly. This is because we're pulling an angle value, and Max's rotations are based on radians. So we need to convert this value to a radian now. So deg to rad will convert this value to a radian. Press evaluate, try it again. Now you can notice what's actually happening is it's essentially just rotating double the amount of the upper arm bone. We need it to rotate in an opposite direction. So I'm going to say deg to rad minus rot x, evaluate. Now you can see that that twist bone is staying aligned essentially off to the top of the shoulder. So it's rotating in an opposite direction. So as a quick breakdown again, the depends on statement makes it dependent and actually work in real time. If I remove this depends on statement, you'll notice that I'm not getting any real-time feedback. I would only get feedback if I animated this and scrubbed the time slider. The equation is simply I'm creating a variable. I'm multiplying the inverse of the upper arm bone, the transform of the upper arm bone with the inverse transform of this point helper that's been aligned to it. Asking for the rotation part of it, converting it to an Euler angle, converting it to degrees to radians, inverting it, and then looking for the x value out of it. Sounds a little complicated, but in practice it's actually relatively straightforward. I want to point out a couple of problems right off the bat with this and show you where this can fall apart on you. One, first part being is if I change the name of my of any objects that are included in my depends on statement and hit evaluate, I now get errors, unknown property transform and undefined, because no longer does $.21 exist. It's now $.21 underscore AA. I'll remove that for now. So it's working again. So I can't change the name of any objects. The other problem is the clavicle to upper arm bone has a lot of degrees of rotation to it. As I discussed before, it can't rotate above being in line with the clavicle. So you can't actually rotate this joint up like this. So we don't need to worry about it going up. We do, however, need to worry about it going down a long ways. This bone can actually be pulled down a long ways, and you can actually notice that as I do this, see if I can get it to happen really badly. This bone will start to twist against these ones. It's kind of hard to see, but you'll actually start to see it twisting out of control. And that's probably happening there, where it's no longer trying to stay aligned. It's actually flipping over on us. We can actually minimize how some of that flip happens by rotating the object that it's calculating the rotations between. If it's flipping when it hits 90 degrees of this one here, and we know it doesn't need to go up past it, past 90 degrees, means we can actually rotate it and cheat it down a bit and say, well, we know we're not going to get up past this angle here anyways. We just simply shouldn't be doing it, or else we're ripping the shoulder joint apart. It's doing something very unnatural. Now it gives us a huge latitude. We can rotate this bone all the way around to here before we ever hit 90 degrees, which would mean the arm would just be passing right back through itself. So there's a good little cheat to stop it from flipping. On the axis forward and backwards, we won't get a flip because it's around the z-axis, and the z-axis flips at 180. It was only the y that was going to flip it at 90. Just like we had the same problem down here with the look-ats. So there's a great little cheat to get around that. The next cheat requires a little bit more scripting again. This next cheat is to get around having name-dependent script controllers. Call it a cheat or whatever you want. This is the way it works very nicely. We're going to use a bit of MaxScript again, and we're going to create a custom attributes. Oops. The attribute is going to hold the nodes that we're currently using in our depends on statement and we're referencing. So we're going to create some nodes that are just going to store them. And we're going to store those nodes in this custom attribute and then reference the custom attribute. So if the name of the object changes, it doesn't matter because we're actually looking at the node itself. The name will change. It'll just pass it right into the custom attribute and right back into our script again, and it won't break when the name changes. I'm just going to call it node store. Sorry, attributes, it should say. And then I'm going to give it a param block. Call it node P. And unlike when we create the interfaces for the hands or feet, we don't need any rollout. We don't need any control interface. We just need parameters to store data in. In this case, we're going to call it UP_arm for upper arm. And we're going to create another parameter called UP_arm P for parent, or we can call it whatever we want, but this is going to refer to the helper. We have to give the parameters a type. And in this case, it's going to be node. We'll just evaluate this script, and it should return back to us an attribute definition. So CA has now become equal to that attribute definition. The next thing we're going to do is we're going to add the attribute to the actual controller itself. We don't want to add it to the object. We want to add it to the controller. So we need to find, in this case, $sign is going to refer to this object, $sign dot rotation dot controller. It's giving us the Euler XYZ controller dot x underscore rotation will give us the one x-axis dot controller will give us the actual float script controller that's on the x rotation of the object. Make this a variable, con equals. So now that's equal to that float script. On the next line, I'm going to say cust attributes dot add. Add to what? We're going to add it to the controller, and we're going to add what to the controller, and that's the custom attribute. You can actually see now that a new track is opened up underneath the rotation called Node Store. Node Store has two controls in it. Two parameters in it, sorry. And let's just go and access those. So con dot node store gives us that node store. Con dot up arm will return to as undefined because we haven't defined this node yet. So we need to do that now. We need to actually give it this node to view, and we're going to be using this node here. Equals $sign. So I just selected the upper arm here, and if I just highlight just con.up arm and evaluate it with a shift enter, it will return back this bone now. So I've actually stored this node in here. Let's do this object now, and this was up arm P. So in up arm P on the controller, I want to store this currently selected object, and the $sign refers to the currently selected object. And so now I have stored the point helper in there as well. So instead of doing this now, and instead of having to call on each object by name, what I'm going to do is I'm going to create a couple of variables and get rid of this. We're going to call this up arm again. I can reuse it, it doesn't matter. And I want to access the custom attribute that is stored on this controller now by saying this, and this refers to the controller itself, dot up arm. So I'm going to access that parameter. Con.uparm is going to be the same as, in this case in here, this dot uparm, because this refers to the controller itself. Uparm P equals this dot uparm P. And let's just do a couple of print statements here. And you'll see when I evaluate this now, it actually returns bone 07. And if I say print uparm P and evaluate, it'll print out the helper object. So now what I can do is, instead of using the actual bone name, I can say, in this case, uparm, and uparm P will replace both of those. And you can see that my twist bone still works. This has actually two effects. If you notice, we don't need the depends on statement anymore. Doing it this way actually is feeding the information right back into the controller. As this node changes its state, it's feeding its information straight back into it. So I don't need the depends on statement anymore. It also means that it's not name dependent anymore. I can change the name of that bone to whatever I want, and you'll notice my twist still works. The evaluate doesn't throw any errors. So this is a great way to make script controllers non-name dependent. It also can make them faster, because in a large scene, if you're having to access $bone07, it's having to search the entire scene for that object. And that can start getting very, very slow when Max is calculating things and making your rig slow down a lot. So there's two really good ways to set up twist systems for your ARM.